Good afternoon, YouTube. Checking out the diversion load today. We've got about 425 watts or so on line 1, and you can see here we're pumping roughly that same amount of power in on line 2, pulling it out on line 1, giving a net power to the whole house of about 10 watts, and we're burning up about 140 right now. So with this system, every 15 seconds, the power changes, the computations run, the diversion load changes, and it's really hard to keep track of what's going on and see what the thing actually looks like running. Yeah, so this is my Synology NAS. So I've tried a couple of things. One is I tried loading up HomeAssistant and then the InfluxDB and Grafana graphing packages by a Docker. And I could get HomeAssistant to run, but I guess one of the issues on the Docker version of HomeAssistant is that what's called the supervisor is not installed, which means you have to go and manually install these other packages that you want to add, or I guess they call them integrations. That makes it a little bit tricky because you have to set everything up manually. You pick your package there, and then you go in and you edit settings, change things around there, and then start the Docker container running, and then you try and see if HomeAssistant can talk to Influx, and I was getting all sorts of problems there. It was kind of a really steep learning curve. So the other thing I tried is, I think they call it the HomeAssistant Core, but that basically gives you the same functionality as the Docker version. It's a little bit different, but it's missing this supervisor package. Again, all the integrations have to be added manually. So I was just having trouble with that. Several years ago when I picked up this new Synology NAS, one of the things I wanted to be able to do with it was run this virtual machine manager, because my old DS1618 Plus had just a 2-core processor and 4 gigs of memory max. Synology didn't enable the virtual machine manager on that particular box, and you really probably wouldn't want to run it anyway because you have to dedicate at least one CPU core to that virtual machines, and then you really want to give it 2 gigs minimum of memory. So you would take your 4 gigabytes of system memory and you'd also cut that in half. One of the things when I selected this 1618 Plus model, it's got 4 cores, and I loaded it up with 32 gigs of memory so that I could have a virtual machine running, or maybe even 2. And so this virtual machine is really neat. I set it up for HomeAssistant to run natively. I gave it a 32 gig disk, and then it's got a network. It's basically a processor running, and then you load the HomeAssistant virtual machine image, and you've got then the full HomeAssistant plus the supervisor package. And so that's up here. So here I've got HomeAssistant running. It's got the supervisor down here. If you run the Docker or the native Synology version, you don't get this here. And this makes it really easy to add packages. You just go to the store, click on Influx, which is the database package, and then Grafana, which is the graphics package. You click on them, install them, and then you just have to do a little bit of configuration and get them up and running. So that was really easy. And then here's the Influx database. So what I can do is I can come in here to my HomeAssistant database, and I can go down to the watts measurement. Here's my home energy monitor from my Vera controller, and then I can click on the current power or the value there. But anyway, that is Influx, and what it does is it basically grabs all the data off of the Vera. So every time anything changes, you can see here at 12, 14, and 30 seconds there was a reading, and then at 12:14 and 50 seconds there was a reading, and 12:15 and 0 seconds there was a reading. So it's just capturing all of these changes in anything that's going on the Vera controller get pulled into this HomeAssistant database. And then I can come over here to Grafana, and here's my home power. So what I have here is, this is my home power, and this is just monitoring that home energy monitor that I have set up. So it's got total power in green, so that's the green line here. Line 1 is the yellow line, and then line 2, power. So that's corresponding to clamp 1 and clamp 2 on the home energy monitor. And you can see here, this is the last 6 hours. So starting out this morning, what do we have here? 300 watts of power, and then the little blips here are the refrigerator kicking on. Yeah, I think here I was running the stove, so the stove element was cycling on and off there. Here's my grid tie power. It's a little bit off the screen, but it's coming up here. Peaks a little over 300 watts. And so over the period of time here the power is 130 down to, looks like about 80 watts. There's maybe 70. Pretty soon here, about 11 o'clock in the morning, there was enough power between the grid tie and then the hybrid inverter that it kicked on here, and you can see the sharing logic here. Yeah, so the line 1 power up here was up here about 120 watts, and then down here the line 2 power was essentially the negative of that, minus 120 watts. And then I, just for testing here, I turned on some more things. I think this was my microwave here, and then this was my coffee machine running here. And you can see I've turned on a couple of things just to get the load up here so we could see it. But you can see how the blue, which is the negative power, is pretty much mirroring the yellow, which is the actual load in the house. And then here's the diversion load, watts. It clicked on just a little bit right there, a little bit right there. It came up here, and then that's when I turned on some other things. I turned on a couple of PCs just for some extra load here. But you can see how that's working, and we're still burning up a little bit. There's a little bit right there, a little bit right there. It's usually when things change. So here's when the refrigerator was running, and then it turned off, and then the diversion load turned on. So the blue is essentially the diversion load code, but this power here is not being used up by the diversion load. It's being used up by loads in the house. I have to come in and shave off little peaks of power. Yeah, so it's about 6 p.m. That's about the end of the solar power coming in. Right around 5:30 when we last had 0 power, and then the green line here went up. Now it's pretty much climbing. We're still getting a little bit of grid tie power coming in, about 100 watts. So this grid tie actually has 2 solar panels. There's one solar panel that faces southeast, and then there's another one that faces southwest, and they're both 270 watt panels in parallel, so I actually get quite a broad power band off of those, all the way from about 6:30 in the morning till about 7:30 at night, although I only get peak of 325 watts. I never get 540 watts combined, but I get that power spread out quite a bit during the day. So hopefully this Grafana panel or chart helped visualize what this system is doing. The blue is all power that I was basically recycling, so to speak. And then the green down here, this was the power I was dissipating. And I think I recycled a lot more power here than I dissipated, because big chunks of this here, I was not dissipating any power. I was using it all. So yeah, if you have any questions about that, if you need any details on any of these things, post up in the comment section below. And as always, thanks for watching.